You're listening to With Intolerance, a podcast for machinists by a machinist. I'm your host, Dylan Jackson of Protein Machining, and this week I am joined by John Socha-Leialoha. Welcome, John.
Good to be here.
So, for anybody who hasn't seen your YouTube channel, which I'll definitely link in the episode description, what do you do? Where can they find you online? All that good stuff.
So my YouTube channel is focused on my hobbies, and my hobbies started with injection molding, but it also covers CNC machining, sometimes some lathe work, electronics, or whatever I feel like doing. And I also have an LLC associated with it called Random Products because I like to do product design and development. And the products are whatever I feel like working on, hence the name.
That's kind of the best way to do it, though. I mean, if you can find the time to do random products, I think that's the dream for a lot of us. So,
oh, it's great. Yeah, I mean, the important thing is not to be stressed about whether or not I make a profit.
Yeah,
because otherwise it's not fun anymore.
Exactly. Yeah. Well, then let's get into your backstory. I know you had shared with me over DM. You have such a wide variety of degrees and jobs and stuff outside of machining. So share as much as you want, but how did you get to where you are now?
So, I mean, one of the things that you probably noticed from my backstory, which is degrees in electrical engineering and physics, is that, and then I work in the software industry as a software architect. I like to change. I like to learn. I get bored easily. So when I was getting my degree in electrical engineering, I started out with one specialty. Okay, now I got that. So I did another specialty. Okay, got that. And did another one. Ended up with 7 specialties because I kept getting bored. And went to college to learn computer engineering. I didn't. I learned everything else. And then went to graduate school in electrical engineering, but then switched to physics because that was something new. And I wanted to see if I could do it. Getting a PhD in physics, why did I do it? To see if I could. Is that a good reason to do it? No. But that kind of sets the stage for, I think, where I am today. So what happened is I was involved in one of the dot-com companies back in the early 2000s. What is it, 2000, 2001, when we had the crash.
Mm-hmm.
And it was going down. So they needed someone to shut down the company. And, I was the last one standing, effectively. So I got to shut down the company. And it was pretty stressful. So I decided I needed a hobby. Well, what's a good hobby? I mean, I like to build things. So I tried boat building. So I built a small rowboat. Okay, that was kind of fun. So then I built a canoe. Okay, that was enough. So it was time to do something different. And so I looked around for different hobbies, and there was a hobby from my childhood, which is model trains. And I realized that one nice thing about model trains is that there's so many different aspects to it that the chances of me getting bored were pretty slim. So I decided to pick that up as a hobby and decided that I was going to focus on scenery because I didn't have the skills to build models. So what happened, of course, is I started to build models and actually won awards for the models. And then decided, there are models out here I don't have, that don't exist. I'd like to help create them. So I worked on someone else's layout. We had someone visit from a company. And so I talked to him and I said, hey, I'd love to design some products for you. He said, well, this is a lot more difficult than it looks, blah, blah, blah. That was a challenge.
Right. Yeah. I'll show you.
So I started thinking about, okay, what can I design? And decided to start with laser cutting because laser cut wood products are still a thing in model trains. Made out of thin plywood, like 1/64th or 1/32nd of an inch thick plywood. And so thinking about it, I thought, okay, the first idea I came up with is a picnic table. No one had a picnic table. Okay, that's pretty simple. Well, it took a bit of work and going back and forth. I found a company nearby that could do the laser cutting. And so decided to launch a company and teamed up with another model railroader who was really good at the details. I'm good at the big picture. Um, so he was good at the shipping and the um, dealing with the orders and the customers and everything else. And I did the product design and manufacturing aspects of things. And so that company grew to the point where we couldn't afford how much they were charging us for the laser cutting. So then we found someone else who was doing it in their house, and they were great. Actually, it was a man and his wife. The wife was Japanese. she, the way she packaged things whenever she gave us parts was just amazing. Way over the top.
Mm-hmm.
The first thing I would do is unwrap it. So there was no value to the customer in having it packaged that way, but it was pretty cool. Anyway, that was a great relationship until they decided to raise their prices. And I did the math and realized we could buy our own laser. So we bought our own laser cutter and, continuing to grow the company. This is a hobby business. So I'm doing this, after hours on evenings and weekends, not making a single penny. The thing about model trains is the way to make money is a lot. I mean, this is the typical joke. The way you make a lot of money is start with even more.
Uh-huh.
Uh,
Yep. A lot of people say that about racing as well. They say, how do you make $1 million racing? You start with $2 million and you go racing.
Yeah, exactly. So there's not a lot of money there, but there was enough to bootstrap the company. And then I decided my partner decided that the company was getting too big when I started wanting to get into injection molding parts. So I actually got a new partner who bought out the first partner. And the new partner wanted to get into more mass-produced products. So we started brainstorming about injection molded products. And we had someone who came to us with a throttle holder for the layout that was vacuum formed. So we licensed that and started manufacturing that. And it sold really, really well. So that I said, okay, it's time to do injection molding. And so I designed an injection molded version of that part. I was using a program called VX.
I think I've heard of it.
Yeah, it was. Let me put it this way. I wish I'd gone directly to SolidWorks.
I think a lot of people who use smaller CAD systems eventually graduate towards the bigger ones for that reason.
Well, it was at the same price.
Oh, wow.
So
that's rough then.
It was rough, yes. So I mean, I don't remember the figures, but I spent quite a bit of money on VX, or the company did, I should say. But then when I switched to SolidWorks, it was just a dream. The thing that made me switch is I came up with a solution to a problem, and the program crashed and I lost it.
Oh.
And I couldn't remember what the solution was.
Oh, no. Oh, that's terrible.
I mean, I had saved things, but the way things worked in that program was really funky, so it didn't get saved.
Right.
Anyway, so I switched over. So that product, took it to a local injection molding house, about an hour away from my house, and they had an injection mold designer, basically a mold maker, who is about an hour and a half or 2 hours away from my house. So I got to go visit him and see his setup, and I was getting really intrigued with the idea of doing my own injection molds at the time. So that was the first product. The second product was something called a Blue Point turnout controller, which is a mechanical way of throwing the switch points from one direction to another.
Okay.
That's under the layout that had a built-in toggle switch. And the toggle switch is important because you need to route power one direction or the other. And so the toggle switch gave you both the power routing and also the mechanical force to hold it in place. So I got a patent on that. And then it was also made in, locally, and worked with the mold designer. And the thing that's really interesting is, okay, so this is my second time doing anything with injection molding. This is a hobby for me. It's not my day job. And go in and show them all the things. And they said, it's so nice to work with someone who knows what they're doing. And I'm thinking, wait a minute. What do you mean? I'm an amateur.
Right.
And I was really surprised to discover that most people designing injection molded parts do not do any research to figure out how to design the parts. I mean, I had added draft angles and was careful about radiuses and everything else, which is why they made the comment. So I was pretty surprised by that, but also, of course, emboldened to decide to get into injection molding myself. So going back to the model train side, we would make these trips periodically, basically outings, a group of model railroaders going out and visiting the real railroad in different places. And typically we would do it in Eastern Washington or California. I was working on, as a slave, as we call it, on someone else's layout. I have never had a layout. I've never been interested in having a layout because I just like to build things.
Right.
So I used to work on his layout, and he would organize these trips with the crew. So one trip we went to the Feather River in California, and we stopped at the workshop of this guy who actually makes products for model trains. And he had this Roland MDX 5 something CNC machine. And that got me really interested. Like, what is that? So he described to me what a CNC machine was. I didn't know. We'll come back to that in a second. Turns out my grandfather worked at Kearney and Trekkie.
No way.
On one of the early CNC machines.
Wow. Because I was just watching Fireball Tool had a video on a KT, and the I guess common consensus is the reason that they went away was that they didn't innovate in the CNC quick enough, compared to Bridgeport or all these other companies that are still around. So it's very interesting to hear.
Yeah, I don't know the details. I'll have to ask my father for more details about it. But yeah, he worked. Kearney and Trekkie did have punch tape CNC machines fairly early on.
Right.
Again, I don't know what the timing is. And my grandfather had a basement with all sorts of machines in it. I have no idea what, because I was not at all interested in any type of metalworking back then. My father had a bunch of stuff. I have no idea what it was because I wasn't interested.
Right.
But part of the point here is that, metalworking is apparently in my genes. It just took a while to kick in.
Mm-hmm.
So back to the Feather River, seeing this CNC machine got me really intrigued. So I started doing some research and discovered the Roland MDX-20 and decided to buy one of those machines. One of the reasons I was intrigued by the MDX-20 is because it was simple and easy to use. Now, simple and easy to use does not mean useful, as I later discovered, because I don't know if you're familiar with the MDX line of Roland machines.
I've seen them, and I don't think I've ever heard someone speak very highly of them. I know they're small, but I've heard that they're like extraordinarily expensive for the capabilities.
Yeah, it was not a cheap machine, and it had an 80-watt spindle.
Right. Yeah.
So,
a couple light bulbs worth of spindle power.
Well, back then, with incandescent bulbs, no.
Right. Yeah, that's fair. Fair.
So it was a very underpowered spindle. But the other thing is that you had to have the cover on to be able to do any work. And so you had to rely on the home switches, and the home switches were not at all repeatable.
Ooh.
And so, I kind of learned that, tricks of being able to get good results. And basically I had to do it start to finish. If I had to, rehome the machine, it game over in terms of accuracy. So, I started out with I don't think I ever even tried to do metal on that machine. It wouldn't have been realistic, so I was doing plastic. And I did make a few masters for some resin um, casting. So I made RTV roll molds.
Hmm.
Nothing for production because, just it's not realistic. So eventually I switched from that to a TAG CNC machine. So I got the TAG, bought it off eBay, and then the first question is, okay, now what? How do I use this machine? Because I had not learned any of the basics from the Roland machine. So, how do you set the 0 point?
Right.
An edge finder. What is an edge finder? Okay, so I buy an edge finder. It's like, all right, that's this little piece that wiggles or can move back and forth, but how do I use this?
Right.
So um, I did find a video that showed using an edge finder. It's like, oh, that's it. That's all there is to it. Okay, so then I started using the edge finder, and I was able to eventually, after a lot of trial and error, get to within half a thousandths of an inch repeatability, which was required for some of the small end mills that I was using. And then, of course, there's the Z height. How do you set that? Well, the machine I had was before they TAG supported ER collets.
Oh no.
Um, so it was just a nut. I forget the details of how it worked. Oh, no, it was a set screw. So you had different nuts with holes in them and a set screw that
Hmm.
you would have to screw onto the spindle. So fortunately, I was doing almost everything with 1/8 inch diameter shafts because I was using such small end mills. So what I would do is I would get the Z down to about where I wanted. I'd make sure that the tool was deeper into the collet, if you want to call that, the tool holder, than I wanted it to be. So I'd get down to about where I wanted the Z to be, and then I'd loosen the set screw and gently drop the end mill down and then tighten the set screw. And that's how I would set Z.
Hmm.
So it was pretty primitive.
But I'm sure a leap and bound over the Roland.
Oh yeah, I could get things done. I could mill aluminum. Not very well at the time because well, I was using a program called Visual Mill
Okay.
Basic for the cam, and there's a lot I had to learn, and it was pretty limited in terms of the tool paths, and I didn't understand feeds and speeds. Read the stuff and it just didn't make sense. I have no idea where it didn't make sense because it makes complete sense now.
Right.
So I don't know what the disconnect was. Um, so I use trial and error. Okay, does it break or not?
I mean, to be fair, I think a lot of machinists still do that. There's the common saying of like push it until it breaks and then back it off 10%. So
Yeah,
you're good in good company.
yeah, but doing it with 10,000 inch diameter end mills gets pretty expensive.
This is true.
So I got to the point where I was starting to feel more comfortable with things. And then, wanted to make injection molds. So I bought a machine. I bought a little desktop machine that had a pneumatic cylinder and, just a clamp that you rotate to hold the mold in place. And then it was back to the same thing. Okay, now what? What do I do with this? How do I use it? How does it work? And so it sat there for a long time until I went to a train show called a narrow gauge convention because it's modelers who model, Colorado. I don't know if you know this, but it's 3 foot gauge in the mountains because 4 feet 8.5 inches, I think, is the normal gauge. It's a lot more expensive to lay that. And so these were effectively, low volume lines, where a long train might be 10 cars
Hmm.
instead of a mile or two long.
Right.
So, the cost of the rails was important. So there are enthusiasts who would go to these conventions, model train conventions. And this one happened to be in Durango, Colorado. Um, and there was a open house of a manufacturer there. And they had a desktop machine and they were making parts on that machine. So I looked at it, and my first thought was, that's it? That's all there is to it?
Right. It's been sitting for this long, and that's all I had to do.
That's right, exactly. So once I realized that, I went home and I started actually working on making some molds. And then I think the next year, I was at another narrow gauge convention and talking to one of the other manufacturers. And he said, here's a product that I really love to have. And it was a slag cart for smelting. When they smelt, they have slag that comes off the top, and then they put it in these carts. They let it cool and solidify, and then they dump it over the edge of a hillside. Not very environmentally friendly, but that's what they did.
Right.
And so there was a museum, a Colorado mining museum, I think it was, in Golden, Colorado. So I went there and saw a slag cart. So I took a bunch of photographs. I took some measurements, created a 3D model, and then created a mold for it. And then I started making products for this company. And I probably made a couple dozen molds, maybe 3 dozen molds for this company. And I used to joke, wasn't really a joke, that I only made products that were not worthwhile making.
But you're having fun. Like you said, it was a hobby, so.
Exactly. Yeah, I had a lot of fun. Really enjoyed it. Learned a lot. Really improved my mold making abilities. And kept doing that until I got burned out on it. So I stopped making molds and kind of took a break. I don't remember. Oh, yeah, I remember what happened. So what happened is then I became interested in creating a Wi-Fi throttle for model trains.
Okay.
You see a pattern here?
Oh yeah. Well, I think I briefly touched on it on an episode within the last month or so of like hyperfixation, and that's definitely something that I wouldn't say struggle with. I actually love it, but like I will, buy all the nice things for a hobby and learn the hobby, and then be like, okay, that was cool. On to the next thing. Like,
well, so I wouldn't say it's a fixation. People who are listening can't see this, but I'm holding up some actual ones that are on the market now.
That's awesome.
So these are commercial products now, but the story is one of those other stories. So I started designing it myself. I used an ESP8266. Some people will know what that is. It's basically like an Arduino, but it has Wi-Fi built in. And it's a really tiny device. And I got it all working. And I actually had it set up so you could have a battery pack in your pocket, and took it to layouts and actually used it. And so there was this company in Pennsylvania, and I was talking to them about me designing that product and them selling it. And they were pretty enthusiastic about it until 2 other people came along who had been working with this company for longer, and basically said, no, it needs to have these features. Long story there. And there's no way he can finish this in the amount of time he says, because he's just one person and we're 2 people.
Motivation.
And by the way, I was almost done. So decided to team up with them. And the first thing is they had a throttle already designed. They had the circuit board already designed, and they had a case that was really ugly that one of their people designed, and it was not at all ready for injection molding. It would have been a lot of work to get it to where it needed to be injection molded. So the first thing I did is I said, okay, I'll redesign the case. The case was kind of angular and triangles and various other things, and the final case is a lot of curves and just feels really good in the hand. So I did all of the plastics design.
Oh, wow.
For the 2 cases, for the 2 products.
For everybody who can't see, they kind of looks like one of those smart remote controls.
Yeah,
with the screen and everything.
Yeah, and you can look, if you look at, go to tcsdcc.com, you'll find the UWT 100, which is the one I was just showing. And then there's the UWT 50. And one of the things that I'm going to take a detour and come back to the plastic design in a minute. So the detour is that, one of the motivations for doing this is to have a product that generated some more funds to pay for more toys. And so at the time that I was doing this, I was also designing a pick and place machine. Um, and I got fairly far along on that pick and place machine. Uh, the first one, so let me back up a little bit more. So um, I actually had a circuit board I designed for Delta 3D printers that used something called force sensitive resistors uh, at 3 points around the plate. You could auto bed level the machine by touching near those 3 points, and it would sense the pressure from the head. So
Interesting.
um, I designed, with the help of a friend of mine, a circuit board that would take the input of those three force sensitive resistors and turn it into basically a on-off, as if it were just a regular end stop detect, just the toggle switch.
Right.
So you wouldn't have to modify the printer to be able to use this. And created the circuit board, and then people said they'd be interested, so I actually made 100 of them. I designed a manual pick and place machine. Manual meaning that your hand is moving it, but it's supported, and you have finer control because you can put your finger on like the bearings, and then slowly rotate the bearings a little bit to get finer control over the position. So used that to make the first 100, and then ended up having a distributor say, "Hey, we'd be interested in buying some." It's like, okay, how many do you want? And I'm thinking, a few hundred more. Yeah, we can swing that. And he said, "Oh, we want 1,000." Like, oh,
Yeah.
now what? So went to Seed Studio in China and had them made there. Um, but that's what got me interested in designing the pick and place machine. So the plan with this model train throttle is that I would manufacture the boards and then resell them through this company. When I teamed up with TCS and these two other guys, they have um, their own pick and place machines, commercial pick and place machines. So they were going to do all the manufacturing. So I just abandoned that project because it was no longer relevant to where I was planning to go. You'll see later that this is coming back to haunt me with some of my recent photos. But when I decided, so after designing the case, then I started to work on the software. And so they mentioned that there was no way that it could possibly be that close to being done. And I'd say I probably had a month or two of work left before I was ready. 3 years later, with three people working on it, we finally shipped the first product. Now, in hindsight, I completely understand their perspective on things, and I completely understand why I was right and they were right. And the reason I was right is because I was using the simplest possible solution, and they were using the most general, elegant solution.
Okay.
So with the way they were doing it, everything was really complicated and difficult, and it took a long time to do it. Whereas I was doing just good enough.
Right.
It's actually something I learned from model trains, which is, if you're building a structure and you go all out, for the maximum level of detail and accuracy, it's going to take you forever. If you want to build a layout, you have to adhere to just good enough.
Right. Well, it's that like fail fast, fail cheap that Saunders always talks about too. Like you just want to like get something out, and then you can always add and tweak and all of that. You don't want to sink all that time into it and then be like, oh, well, that was all for a waste because I don't like this, or this has all changed since I started this project a year ago or whatever.
Yeah, there's another concept based on lean called pivot or persevere. And so with the pick and place machine, that's where I did pivot. Mm-hmm. Because I came to the conclusion that there was no value in persevering. You can tell I'm also a big fan of lean and agile and all of these other methodologies. So getting back to the throttle, once the while working on the throttle, I was still also doing some work with injection molding. I had some. So let me back up. So I had this company that was doing the turnout controllers and the laser cut kits and the throttle pockets, and it got to the point where it was the gross was too large to be a hobby anymore. The profits were too small to be anything but a hobby.
Mm.
So I made the decision to sell. And once I did that, that's when I got into doing the injection molds for this other company.
Okay.
But I got to keep some of the equipment, including the TAG. So I started doing some other things with the TAG, and I don't remember what. And then I got Tormach Envy.
Okay.
The thing that, I mean, there were things that drove me nuts about the TAG. I mean, the big one was, setting the Z height. And changing tools, having to be next to the machine all the time, and watching the pictures of the Tormach with TTS, that seemed really cool to just have the tools pre-measured and just change the tools.
Right.
I really liked that idea. So I started looking around for Tormachs and found one that was available for sale. It was a 770. I had decided I wanted a 770. And the reason I wanted a 770 is because I wanted the 10,000 RPM, 10K RPM spindle.
Right.
And it was also a nice size. The 440 was too small, in my opinion. So I found one that was available for sale for 10,000. But there was something I was concerned about, which is Jason Snyder had done some videos about his experience with the Tormach, which is pretty well known.
Oh, yeah.
And I did some research into that and kind of concluded that there's a small number of Tormachs that have quality issues that result in backlash being significant. For the type of work that I do, that's not acceptable. If you have a couple dot backlash with a 10,000th diameter end mill, it's not going to end well.
Right. Yeah. I mean, at best case, you will have a ugly mold. At worst case, you're going to be pulling out your hair forever.
No. You're going to break the tool.
Yeah.
The end mill will shatter. So I wanted to see the machine and get an idea what the backlash was like before committing to buying the machine. And I kept bugging them to visit. And finally they said, okay, we can set up a visit, and it's now $15,000. Like, wait a minute, how did it go from 10,000 to 15,000? And then I did the math, and at the time, I could buy the machine that I wanted, brand new from Tormach, for 15,000. So, sure, it had a few things that would bring the price up, but I didn't care about those things like the rapid turn. Mm-hmm. So I said no thanks, and then thought about some more. I was really reluctant to buy a new Tormach because I was afraid of getting one of the few that had issues and going through Jason's experience.
Right.
So, and then I became aware of a Facebook group for TAG machines. And on that Facebook group, there were a couple of people who were selling upgrades to the TAG. One was a new frame, a very, very rugged frame. And the other was a TTS spindle and power drawbar.
Oh, wow.
So I ordered each of those and then started upgrading the TAG. I called it a TAG Mach.
I like it.
And was making good progress with upgrading it when I learned about a Haas OM2 that was about an hour drive from my house. They had two for sale. I'd never heard of the OM2. So I had heard of VFs and mini mills and that type of thing, but never heard of the office mill. Mm-hmm. So I looked it up, and when I looked it up, I realized that it was actually the perfect machine for me because It's a machine that's designed for precision rather than uh, hogging material and making, focusing on it's not good at material removal. And I'll get back to that in a minute. But with a 30K RPM spindle, it had a fourth axis. Um, they were asking, I think, I forget what they are asking, 25 or 27,000 for it. And it had a fourth axis as well, and came with um, 25 tool holders.
Mhm.
So it was a really good deal.
Yeah, that's kind of
But it
hard to
was
beat.
but it was more than I wanted to spend. My budget was around 15,000
Mhm.
for a 770. And so I thought about it for a long time, and I thought about, okay, how would I feel if I don't get this machine? And I started to feel bad. So then I knew I had to buy the machine. That's my usual technique with this type of thing. How would I feel if I didn't get it? My
Right.
wife taught me that.
That's smart. If you can walk away, you know that it's not right for you.
That's right. So I made an offer at 22, and they accepted it. And so then I had to learn about rigging and getting it into my garage. My workshop is a 17 by 21 foot space behind the garage. So it's built on the back of the garage.
Okay.
So there are double doors from the garage to the workshop. This is a remodel that we moved into about 2 years ago. And so when we designed that workshop, I had the choice of either having um, the floor at ground level outside the workshop or at the garage level, which was about 2 feet down. And I thought it would look nicer if it were at the ground level.
Oh no.
Yeah.
I see where this is going.
So that meant that to get the house in there, it had to go through a double door and then up 2 feet onto the slab. So did find a rigger who was able to get it through there and up onto the slab. And that's one of my videos, and it's quite impressive. I think the clearance that I had was about half an inch
Oof.
to spare. So it's a good thing I went with an office mill because nothing larger would have fit.
Jeez. That's like, I mean, a perfect machine for you though. And like it's 50% more than you wanted to pay, but it's easily, triple the machine that you would have gotten for 15 grand.
More than that.
Yeah. Because you
Yeah,
got
I
a
mean,
tool
there's
changer, a fourth, all that stuff.
yeah, I mean, I looked at what a compact mill, which is effectively the same machine, would cost new, and I spec'd it out, and it was like $90,000.
Yeah, they're not cheap.
They're not cheap. So the resale value on those machines is, goes down a lot faster than other Haas machines because it's probably, such a niche market. But as you say, yeah, it's the perfect machine for me. So, and it was able to fit into my workshop
Yeah, just barely. It sounds
just
like
barely.
oof. Ugh.
And it was the first thing to go into the workshop. So
Oh, perfect.
the house was not finished yet, but the workshop was. So it was the first thing moved into our new house.
Yeah, you got priorities. I understand.
Yeah. So then I had to learn how to use it, and so my experience was. Oh, and by the way, at the time this machine came up, as I mentioned, I was almost done with the TIG mock. I did finish up the TIG mock. I did 2 projects on it, and then I sold it. There, when I bought the Haas, I actually asked them to keep it there for 2 months before moving it in because the workshop was not quite ready. I needed 2 months before the workshop was ready. So that gave me a little bit of time to finish up the TAG upgrades and get experience on it. The good thing about that is it gave me experience with different tools, with using Mach 3 with the tool table, which is not something I'd done before. And I also, did some work with that required cutter compensation. So
Mhm.
there are a bunch of things that I learned from that process that I was able to bring with me to the HOTS. But the first thing is, getting the HOTS in there. And I'm thinking, okay, how do I level this machine? Did a lot of research, got some precision levels, and started trying to level the machine. and then discovered that this is not like other Haas machines. So it turns out it's designed so you can put casters on it and just roll it onto a freight elevator and move it to another location in a building,
Oh, wow.
and then just start using it. So having it be leveling it is not the same story as a mini mill or anything else like that. It doesn't have to be as precise. But the other thing is you don't have the the twist that you get with other machines. So I went through all this effort trying to figure out how to level it and discovered that it wasn't relevant.
That's, I mean, really nice though for you, because leveling could be a real bear starting off.
Yeah, I did watch Haas maintenance videos that made sense, so I was able to figure out how to do it. So got it ready to set up, got it hooked up to 220, and then the question is, okay, now what? So I've only used Mach 3. I've only used my tag. This is a huge jump from
Oh, yeah.
that. And okay, turned it on, figured that out. But then what? So I had to read the manual and go back and forth quite a few times. And I have this on video as well until I finally got it moving. And then it's like, okay, now what? So there were I decided to take it slow and, kind of learn things a little bit at a time. And then the NYC CNC Johnny 5 collaboration project came up. So I signed up for that. And I'm thinking, okay, this is the perfect machine for building one of the parts. So they gave me this really tiny part. I've got one somewhere on my desk, but I don't see it right now. I made that part so many times, and I just could not hit the dimensions. It was driving me nuts. I'm thinking, okay, this is a really precise machine. Why am I not hitting the dimensions? It took me a long time to realize that the tip on my Imperial Heimer, was a metric tip.
Oh, no. I've heard of a few people doing that on like the machinist Facebook group, and it always catches everyone out because they're so close.
They are. So that's why I was not hitting my dimensions. And I was getting stressed out because there was a timeline, when I was supposed to send this off to Saunders Machine Works. And I finally figured it out and finally ran a part after changing the tip. And then dimensions came out just fine.
I'm sure. Yeah. Oh, boy.
But that wasn't the first part that I made on the Haas. That was I think the second part. The first thing that I made were toe clamps to hold down the vise. And that's a whole other interesting story. So that the OM2 has travel of 12 inches by 10 inches. So it's pretty small.
Mm-hmm.
The amount of space between the table and the back when it's all the way at the back, and the table in the front when it's all the way to the front, is not a lot. Okay, so that means you're pretty restricted on the size of vise that you can put on the table. So I said, okay, I'll get a Kurt vise. It's like, no.
Too big?
So I looked around at all these vices, and I ended up getting a Schar's 4-inch vise that is no longer sold. It's not a great vise, and I have finally found a Kurt vise that will fit. It's a tool room vise.
Mm-hmm.
The number of vices that will fit are pretty restrictive unless you go over $1,000
Right.
for the vise.
Yep.
Then the number of vices available starts to increase quite a bit. But, this is a hobby. I didn't want to spend that much. So I'm still using the Schar's vise. And at some point, I do plan to get the Kurt tool room vise, which is about $750.
Okay.
Anyway, so I made the toe clamps for that out of 4140, which is the first time I had ever milled anything other than plastic or aluminum. By this time, I had switched from trial and error, by the way, to using GWizard. So I started using GWizard when I was still using the TAG. And since using GWizard and figuring out the things I need to do, um, I've only broken end mills as a result of making stupid mistakes with CAM.
That's great.
So
That's really great.
yeah, I mean, I just the mold that I made yesterday um, had I went down to a 15,000th diameter end mill, and which is for me it's 15 thousandths. That's easy. Um,
Well, I think you posted yesterday, or the day before, something about like, oh, I usually use bigger end mills, like 1/32, and I was looking at that. And I'm like, that's tiny. Like that's not a big end mill.
so the mold I was doing yesterday, the roughing end mill was 1/16 inch.
Wow.
So uh, yeah, I'm used to using small end mills all the time. I mean, we'll come to another project in a little bit, but there's one case where I was using 1/32 inch super long reach end mills.
Ooh.
Um, like I forget how long, like 20 millimeters.
Oh,
Um,
geez. That's
yeah,
insanely long. I thought you were gonna say like 10XD or something, and I was like, yeah, that's pretty long, but yeah, that's a lot.
yeah. So where was I? So the Saunders part, as I mentioned, I was using GWizard for that.
Mhm.
Um, and that went really well. And so then I started working on. Oh yeah, I was talking about the vise. So that vise, I think I get a little bit of what's it called when the front the jaw moves up a little bit.
Jaw
So
lift.
I think I'm getting a little bit of jaw lift. Um, I'm getting away with it because I always surface the mill. I mean the molds before I cut the cavities. So if there's if it's off in thickness by 1/1000ths from one end of the cavity or the core to the other, it's not a big deal. The machinist doesn't care because I'm the one who's opening and closing the molds,
Right.
and it's not going to make a difference.
Yeah.
Um, so I'm able to get away with it. But if I want to go the next level of precision, where that matters, then I need a better vise. So I'm just living with the vise that I have for now. The next major project that I remember getting involved in using this machine was 12 molds in 12 days.
Oh, jeez. Just in runtime alone, that's a little tight.
Uh, yeah, so I think it was actually 13 days, but I called this series 12 molds in 12 days. And this was for a company that was in Southern California at the time, ModMount, that had a bunch of products that they needed to get out for Kickstarter. And they had a Morgan press. I have a Morgan press. We'll come to the injection molding machines in a minute.
Yeah, we got some questions about those.
Yep. So the he had all of these molds, and I bid on them. And of course, I always underbid. One of the reasons that I underbid, it's intentional, is because then I don't feel as much pressure. Because I can say, I am underbidding, so I may not be able to deliver on time, etc.
Right.
So I have a way out of that, and I can reduce the pressure on me, and therefore keep it fun.
Mhm.
So I'm okay with underbidding. I'm okay with leaving money on the table because it helps with my stress level. So didn't. Of course, that changed once I started working on the molds and started having to make the parts. And
Start cursing yourself. Why did you do this?
then my bandsaw died.
Oh, no.
So I had a Harbor Freight, the small one,
Mhm.
bandsaw that I used for, 15 years before it died. And I decided to try to fix it, but because the bearings were bad. And I just couldn't get, there was one shaft I just could not get out. I couldn't get the bearings out. No matter what I tried, I couldn't get the bearings out. And so the next step was to apply heat. I don't have any torches. I thought about getting a torch, but I was already up against the limits of that bandsaw. It was a 4x5, I think. And so I decided to buy a grizzly bandsaw, the larger size,
Mhm.
so that I wouldn't be up against the limits all the time anymore. And of course, it took a while for that bandsaw to arrive, so I needed something in the interim. So I bought a cheap Harbor Freight, handheld bandsaw, uh, and used that to cut up the blanks for the molds until I got the new bandsaw. So this happened during the 12 molds in 12 days.
Oh, jeez. So you're cutting what, 30 pieces or 26 pieces, depending on how many extras you wanted, just to get the
Um,
molds out.
well, 24. Yeah.
Okay, so you just kind of you made every mold perfect. That's
Well,
pretty good right
okay.
there.
I didn't, but I don't remember how many pieces I scrapped. Not that many, probably 3 or 4.
That's not too bad.
Um, uh, because most of the time when I made a mistake, like breaking a tool, it's recoverable. It's only the tool that gets harmed. The mold doesn't get harmed. So it's just a matter of going in there, replacing the tool, and then figuring out what I did wrong with the tool path, and then running it again. Um, One of the things that I've learned is, I use a Heimer
Mhm.
for picking up the coordinates, and then I use the vice as the Z. So I get very good repeatability. I think I'm getting a few tenths repeatability. I'm not really sure. But when I'm putting these tiny end mills back in and rerunning things, I'm not seeing indications that I'm off by enough to impact the quality of the molds. So as I mentioned, I used a lot of super long reach end mills on this because there were some really deep cavities, and that means that running at 30,000 RPM, um, but taking a depth of cut of like 1,000ths of an inch or 5/10ths of an inch,
Oof.
because if you take more of a depth of cut than that, then the deflection is going to be too high, and you're going to break the end mills. I mean, one of the things that I really love about GWizard is the deflection
Mhm.
readout, because it'll estimate how much deflection. So I want to keep that well into the green so that I don't break end mills, and that's I think the main thing that is keeping me from breaking the end mills, which is keeping the deflection low. So with those super long reach end mills, that's the primary limitation, the deflection. Um,
Definitely.
the longest job that I had for that was, I think, 12 hours. One of the things that, when I was looking to get a Tormach, I decided I didn't need a tool changer because, I didn't really see the value of having a tool changer. When I got the Haas, it came with a tool changer. It's like, okay, well, it's not an option, so okay, fine.
Right.
Doing that 12-hour job, those 12 molds in 12 days, absolutely set completely in my mind why I never want to have a machine without a tool changer.
Yeah, I can't even imagine not having a tool changer at a mill. So
Yeah.
I'm, I'm sure.
And I was thinking, okay, 20 is plenty. I'm never going to need more than that. You know where that goes.
Oh yeah, yeah. No, I mean I've got 21 and then 22 in the F, and they just in Japan released the new versions of the Speedios that have 28, and I'm already like lusting. I'm like, oh
Oh
man,
yeah.
that would be amazing. 33% more tools. Sign me up.
So one of the things that I did, I thought a lot about how to set up the tools in the machine, and read what other people were doing, and finally settled on I want to have the first half of the tools in the tool changer constant.
Mhm.
So they're always the same tools. Um, it's actually a little bit more than that. And then I also have tools 19 and 20 are always the same. So um, only the ones in between are ones that I change, for the specific job. And that works out really well
Oh yeah,
because, I do use those other end mills pretty much all the time, like the 3/8 inch rougher. That's my material removal tool.
hmm
One thing that people don't realize is, okay, this machine has a 5 horsepower motor, spindle motor. And so it sounds like okay, that can do some serious roughing. Then you read the manual, and the manual says, do not use tools larger than 3/8 inch diameter. and do not use depth of cut or width of cut more than about 20%. One of those is 25%. I don't remember which. Because I don't remember which, I just used 20% for both.
Mm-hmm.
Reading that in the manual made it very clear to me that I have to be careful with this machine because it's not designed for those side loads. And so I was thinking for a long time, okay, why on earth does it need a 5 horsepower spindle motor? And it suddenly occurred to me recently that it's to ramp up to 30,000 RPM.
Right. Yeah, because I'm sure it's belted
Yes.
down to the 30,000 RPM. So it's
Yes.
probably super reduced as far as torque goes actually at the spindle.
Yeah. So once I understood that, I started to treat the machine very differently. Before that, I was trying to increase the the material removal. And then once I read that, it's like, oh, no, don't want to do that because that could be a $7,500 bill for a new spindle.
Right. Yeah,
Don't
that's
want to
the
go
last
there.
thing you want.
That's right. So I've been very careful with the machine. And because I'm making injection molds, that's just fine. Because, typically with injection molds, how long it takes to make the mold is much less important than the quality of the mold. So if it takes a little longer to make the mold, that's not a big deal. But again, most of the molds that I'm making are for desktop machines. So we're talking about something that's 1 inch thick aluminum for each side
Mhm.
and 3 by 4 inches.
Yeah, so not that much material removal anyway.
Yeah, and particularly because you're leaving the bulk of that material and you're only cutting out the cavity. These machines can't handle very large cavities, so you're not dealing with a lot of material removal anyway.
Well, maybe let's get into that first question then from Tuck's Garage about injection molding. We can get into what you have. His questions were, what do you need to basically start on it? Just first starting out in injection molding. What do you need to be an advanced user, and how much space do you need to start? So let's get into what machines you have, what you started with, what somebody could start with now, all that stuff.
Yeah, so the first thing I think that you need is where people don't start is they don't start with understanding what's required to injection mold. So quite often people start out with designs that cannot be injection molded. They don't have draft on them. They have thick walls. They have undercuts. So the first thing is to do a little bit of research into injection molding. And, a little bit of a plug here. I've got a bunch of videos on my channel that will help you understand that process.
Yeah, I'll definitely link everything in the description.
And if there aren't things there, people can request content and I can add that content. But the thing is, quite often people design parts that cannot be injection molded for one reason or another. They're too complicated. They have screws that are inside them. They have clips that are definitely undercuts. They're too large. So people tend to focus on like what volume of plastic can this machine inject. That's rarely the limitation. Usually the limitation is clamping force, which is keeping the mold halves from separating. If the mold halves start to separate, then the plastic starts to leak out all over the place and end of game over. So the usual rule of thumb is you need a clamping force of about 2 to 2.5 tons per square inch of cross section of the part.
Okay.
Desktop machines typically have clamping forces on the order of 1,000 pounds to maybe 4 tons.
Okay.
So if you do the math, you can tell that 2 square inches is kind of pushing it. And I see people who say, okay, I've got this part that's 6 inches long by 2 inches high, and I want to do this on a desktop injection molding machine. And does it have enough cubic inch capacity to be able to inject the plastic? So you can see how, that's the wrong place to start. You really have to start with the cross-sectional area and figure out, can you even do this on a desktop machine?
Right. Yeah, I
And
never would have even thought of that.
quite often the answer is no, you can't. The next thing that happens when people, I mean, the latest thing is people are looking at 3D printed molds because they're thinking, okay, it's a lot easier to create 3D printed molds than to learn how to do CNC machining and create molds out of aluminum. There are a couple things that people are not necessarily aware of. First of all, is you still have to learn all these things about draft, undercuts, etc., to be able to design a good mold. That still applies. Clamping force still applies. But another thing that they don't think about is heat removal. So the plastic needs to solidify, and the way it solidifies is by cooling, and the way it cools is by coming into contact with the metal surface that cools it. When you're dealing with aluminum molds, the cooling typically comes quite quickly just from your radiant. The aluminum is so conductive, thermally conductive, that it just radiates the heat away very quickly.
Right.
With steel molds, you have to have cooling channels and water cooling and that type of thing. But with aluminum, you typically don't have to do that. With 3D printed molds, thermal conductivity is pretty bad.
Oh, I never thought about that, but that makes total sense.
So that means you have to let it cool for a long time before you can take the mold out of the machine. If you take it out too soon, the plastic is still going to be flexible and you're going to distort the part. Once you do take it out of the mold, if you don't have enough draft angle, then it's going to be harder to get it out of the mold. I run into that all the time with metal injection molds, where I have to use a knife or something else to pry the part out of the mold. You can see if you have to do that with a 3D printed mold, you're going to damage the mold pretty quickly.
Oh yeah, definitely.
So the life of the 3D printed molds is not going to be that high. Another thing that people don't think about is that for 3D printed molds, you have to use an insert. And so there are companies that sell these mold bases that have tapered area, and then you put the insert into the tapered area. The thing is, if your dimensions aren't exactly correct, the mold halves are not going to close correctly. So quite often people end up doing sanding, etc., to prep the insert so it'll fit. So you can see how you're spending a lot of time just trying to deal with the different things that are going on. And what that means is 3D printed molds are, even though they sound really attractive, do have a lot of downsides. So what I would encourage people to do is to learn how to do CNC machining. Don't start with the product you want to make. Start with something simpler and work your way up.
That makes sense.
As to the machines, so there are some machines out there that are really cheap, like a few $100s, that are really attractive, but they're also crap. There's one machine out there that has, so you have a cylinder, which has the heating chamber. That's where you put in the granules of plastic and then it melts. And then you push it out the nozzle on the bottom. So you have a cylinder a ram that pushes the plastic down. And you want to make sure that the clearance is pretty tight on that and everything is smooth. One of the machines that is available has a stack of washers that have been machined as the ram.
Oh. Yeah, it doesn't sound good.
No. So people complain all the time about how the plastic leaks around the ram and then things get gummed up and stuck. Yeah, but that's why. I mean, the other reason why is because if the chamber is too short, you don't have an area of the chamber that stays cooler. So you want to have the heater band and then some area above the heater band for the cooler plastics for the pellets, so that when you're pushing down on unmelted pellets rather than the melted mix, because again, the plastic escaping around the ram is going to be because you're pushing down on melted plastic rather than the pellets.
Oh, interesting. I wouldn't have thought that you're using the unmelted plastic kind of like a gasket or something.
Yeah, exactly.
That's really interesting.
So it's tempting to get these cheap machines, but you get what you pay for if you're lucky. And in this case, you're typically not lucky.
So, what machine would you recommend for somebody just starting out?
There's a set of machines that are DIY machines called the Beagle Buster 3D. I do not have experience with them. You can build them yourselves. How capable they are, I don't really know
I would imagine
because,
it's up to what parts you use in it if you're building it yourself too.
well, you buy the critical pieces like the RAM and the heating barrel and the heating bands from the company Beagle Buster 3D. I'm not sure the name of the company.
Oh, okay.
And then the things that you're buying and building yourselves are things like the frame and the either the air cylinder or the hand pull mechanism.
Mhm.
Um, so that's certainly one way to start. All the machines that I have are commercial machines that I bought used. So the first machine I bought was an Emco, probably a 50-year-old machine that has a pneumatic cylinder and then a clamp that's just like a vise. Uh, then I have other machines. I have a Traven, which is a machine from England that has a very good price, but they won't sell to the US for liability reasons.
Interesting. Huh.
So I bought mine from Canada. It was used at the time. I've had it about 10 years. But the machine was a 220-volt machine, and I didn't have 220. I only had 110 in my house. So I bought a step up transformer. It was not that expensive, and it's been great because it's not a lot of power that you're dealing with. Um, so, I mean, the Traven is a really nice machine, but there are more and more machines that are out there. Um, Again, what I would suggest though is to focus on your CNC machining skills first. Get to the point where you think you have the skills to be able to make a mold before investing in a machine. One of the other advantages of doing that is, the longer you wait to get a machine, the more options will be available out there.
Right. And then how much space do these usually take up? I mean, is it just a desktop for most of your
Well, my
machines?
my first machine is probably about it's less than 12 inches wide and probably 18 inches deep and probably 2.5 feet tall.
Okay.
And I don't know how much it weighs, but I can lift it up and put it on the floor when I'm not using it. So they're they're not that large.
Okay. So it
Uh,
sounds like pretty, if you already have, a machining background, it sounds like a pretty accessible hobby to get into.
it is, yes, absolutely,
Okay. That's great.
yeah. And then the largest machine I have in use at the moment is the Morgan, which is about 350 pounds. And then I have another machine which is 1,100 pounds that is waiting for me to bring it up. Um, so that one is fully automatic.
Oh,
And
cool.
after I bought that, then I bought another one which is a in between. It's a floor standing. It's in between It's in between the Morgan and my desktop machines. And that's something I'm going to refurbish, put back together, and I'm adding modern electronic controls. So it will be fully automatic as well, and I have some products in mind um, that where I don't want to sit in front of the machine and make the parts.
Right. Well, that sounds like it'll be a lot of fun. I've seen those run, like on Instagram and stuff, and it seems like once you get them going, man, they just print money as long as they're reliable.
Yeah, and there are multiple machines now, tabletop machines that are fully automatic that you can get from different places. There's Robot Dig in China has a machine for about $7,500 that I think I've heard good things about. There's some domestic ones as well. There's one, the Micromolder, that was a Kickstarter,
Mhm.
um,
I remember seeing that one.
which because of COVID, they ran into a lot of supply chain issues and had to basically go down to a single person. So they're and also the cost of all the materials went up, so they're not in a good shape financially, which is
Ooh.
unfortunate because not all of that was outside of their control and not anticipated because when they did the Kickstarter, it was before COVID.
Right.
So their timing was poor.
Oh, poor guys. That's
I know,
that's
I
definitely
know.
rough.
And it sounds like it's a really good product. So I imagine you'll start to see more things like that in the $10,000 range that are very, very capable.
Awesome. Well, the next question we had from Karakuri PGH was you wanted more watch case details and how you came into that work, and that's a video series of yours that I've watched, and we had talked about. But it's such a cool take on a watch case, 3D printed in the machine. So, kind of, what are you doing there, and then how'd you get into that?
So the way I got into that is through my YouTube channel. Thomas, who is the person behind the watch, he's actually from Montana originally, but he lives in Milan, Italy. Um, so he contacted me and said, we have this tight deadline. We have this watch that needs to be milled to tight tolerances. Are you interested? And I'm thinking, tight deadline, tight tolerances, hobby. Not sure
Right.
this is a good match. So I said, given that you're in Milan, there's this guy in Bavaria, Stefan Gotteswinter, who might be a better choice to work on this because I know Stefan could do this.
Mhm.
He could do it in his sleep. And Thomas said, no, I want you to do it. He said, I can tell you're really meticulous and that you would do a good job. So I agreed to do it. And had to really push my skills and to learn a lot of new things, which is what makes it fun.
Oh yeah.
So I basically this was my first time using ID clamps. So I got the order them from McMaster,
Mhm.
um, and then read the information on how to machine them, learned how to machine them, got them hooked up. Also needed to learn how to use my fourth axis. So I had to get a vise. I ended up getting an EDM vise, self-centering vise, and then I made my own mount adapter to the Haas rotary, the fourth axis. So a whole bunch to learn there, but it actually all turned out really well. This was also my first time doing stainless steel. So I was really concerned about stainless steel. I mean, there were some details like the holes for the screws are the pilot drill is 1.1 millimeters in stainless steel,
Oh boy.
five millimeters deep.
Oh. Well, and it's 3D printed, so it's not, not exactly the most consistent material.
Possibly, not sure about that. So far, it seems to have been pretty consistent.
That's good.
Um, so just lots of things I wasn't sure about, but I dove in and decided, like for the holes, to get a carbide drill, and I have not broken a drill yet.
Good.
So again, G Wizard to the rescue. Um, that's been uh, it hasn't led me wrong. So I spent a lot of time working on that and basically meeting the specifications as they had it. And then there's been a pause while they've gone back and are redesigning the watch. So one of the things is, another thing is that it had screws on the back and 1.4 screws. And so that means I had to thread them, with a tap. And
Hmm.
so I was really concerned about doing that with machine tap because I couldn't find any spiral flute taps in that size at the time. So that meant it was a straight flute tap, and just was not convinced it was a good idea to try to use rigid tapping for that.
Hmm.
So I tapped them all by hand.
And you did what, 10 of them or something like that?
It's 8 per watch,
But how many cases did you do?
6
Oh, yeah,
that
that's
I
more holes
that
than I would want to tap at that size.
6 that I shipped.
Yeah, that's rough for sure.
Yeah, I ended up doing a total of, I think I went through 10 cases as part of this. Um, so definitely made some mistakes, learned a few things. Another thing is the the mechanism itself is contained by some clips, and the
Hmm.
clips go into a slot. So the slot is, I think, 20 thousandths of an inch deep. I mean, thick, but it's pretty deep. So I also got a slitting saw that I use to mill the slots because that's an undercut feature.
Right.
Um, and again, I was pretty nervous about that, but GWizard came through. Again, they worked perfectly. I was really concerned about work hardening with everything that I did, and so far I've had zero issues. Everything is just machined beautifully. So I am quite happy with how things have gone. Anyway, so now we're up to the next revision. The next revision, in the first one, we just kind of did what we needed to do to get it put together. So that means the crystals were cemented in place with some crystal cement. But the watch needs to be a 100-meter watch.
Oh, okay.
Well, okay, so 100 meters doesn't think what you think it means. What do you think 100 meters means?
I would have thought pressure at that depth.
For how long?
Oh, I don't know. I know it's not very long. I've seen the testing machines and they like bring it up to that and then drop it off almost immediately.
So it turns out 100 meters means it's safe to swim,
Right.
but not to dive to 20 feet.
Right. Because I think the diving watches are usually what, 200 or 300 meters? Something like
300 meters, yeah. And so I didn't realize that. So I'm thinking, how on earth am I going to make it so you can dive to 300 feet? Because I've been down to 100 feet. And it was nice to learn that I didn't have to make it so that I would have to go that far. But what it does mean is that you have to have these high trowel gaskets
Mhm.
that provide the seal. And then there's an O-ring on the back. And so I'm trying to figure out, okay, what size, what dimensions do I need? What is the press fit for these to get that type of depth? I cannot find the information. One of the things that I'm learning about this is, okay, before this, I really didn't know much about watches. And definitely was not a watchmaker. I didn't know what watchmaking was because I thought what watchmaking meant you built a watch. I've learned that watchmaking means you repair watches.
Yep.
And so, I started reaching out to watchmakers to ask all these questions and crickets. And after a while, I realized that the reason I'm getting crickets is because the number of people who actually design and make new watches is pretty small. And there isn't a community that I've found yet of people who actually design and make watches and are sharing with each other. So that means I'm figuring this out on my own, which is what are the right tolerances for like the stem tube, which is press fit in. What are the right dimensions for the holes for the crystals so you get the right press fit? I followed the dimensions that are published, and for the front, it was a push fit. For the back, it fell out.
Oh, no.
So then I used my micrometer to measure the outside diameter of the gasket once it's on the crystal, and it was 0.3 millimeters smaller than the book values.
Wow.
So, so you can see there are a lot of challenges figuring out what the right dimension should be.
Oh, yeah.
And so I've pretty much decided I'm going to have to use trial and error. But then I did have one person who replied in one of the watchmaker forums who said rule of thumb is, I think, 1/10 of a millimeter.
Okay.
So that's about 4 thousandths of an inch, roughly.
Mm-hmm.
If I did the math correctly.
Yeah, 0.1 of a millimeter is 3.39.
Yeah. And so that sounds like it's realistic for a plastic gasket for a press fit to get 100-meter depth. So that's what I'm going to try. When I did the last gaskets, I did not have an inside diameter micrometer that was large enough. I had 1 to 2 because, 0.2 to 1.2.
Mm-hmm.
But the opening was about 1.5 inches. So I had a video that I wanted to get published. A lot of these things, quite often are based on trying to get a video out. And so I realized, okay, I can make my own gauges. So I used my lathe to make some gauges of different diameters so that I could test the hole. And that was a lot more work than I thought it would be. So I stopped after 3 of those. and ordered a 1 to 2 inside diameter micrometer.
Yeah. Well, like I sent you, I've been kind of going down the watchmaker hobby as well. I've taken apart a couple watches now, and I've been looking into how they're constructed and restoring them and all that. But I have found equally zero information online. Like, it is very surprising how little is quantified. But yeah, it's frustrating, coming from machining that is getting to be fairly well documented online, and then you go jump off into the deep end into watchmaking, and you're like, I just want to know this simple thing. Like, where do I find, you know, crystals for this size? And it's like crickets. It takes hours of looking online to find the one part you need or something like that. So
Yeah, and I've found resources like
mhm.
slinger.com has some good resources. They have a YouTube channel that has some good content on it. Wristwatch Revival.
Yeah, that's how
Um,
I got into it. Actually, is I got recommended one of his videos, and then I was like, oh, this is really cool. I was like, oh, broken watches are pretty cheap on eBay. Maybe I'll grab one of those and some of the cheap tools and start, playing around with it. And
yeah,
it is a expensive rabbit hole to go down. I'm warning anybody listening.
I've not yet met Marshall, but he lives, I think, within 15 miles of where I live.
Oh wow,
Um,
how cool!
but again, I've had no direct contact with him.
Yeah,
I mean, not surprising. His channel has just taken off like a rocket.
yeah.
His production, I mean, his videos are just amazing.
Oh yeah. Well, it's like kind of a soothing narration as he's doing something small and mechanical, and it's a lot of fun to watch.
Yeah, and actually, as a result of watching his videos, I did uh, experiment with a different style of making my own videos, and have learned from his videos that have helped improve my videos. So I've gotten that out of it as well.
That's great. That's really cool.
But in terms of watches, yeah, a lot of it seems to be trial and error. So I've got the video I did just recently on the first watch seal,
Mhm.
and then I did the pressure test, and it failed, which is not surprising. Because I've got one of the pressure testing machines that can go up to 6 bar, which is about 60 meters.
Okay.
Um, so now I've got the inside diameter micrometer, and I've got the tolerance that I'm going to try to hit. So I'm going to do that next and see if it passes the test. And if it passes the test, then I can move on to the next challenge. One of those challenges is using a thread mill. So I got a 1.4 millimeter thread mill.
Hmm.
Um, and the thread milling feature in Fusion 360 is kind of broken. So it does not correctly model the shank. And so if you look
Oh
at
right. Hmm.
the what you get in Fusion 360, it's going to say you have collisions when you really don't.
Yep.
And so I found a video on NYC CNC that showed creating a form tool. And with the form tool, I can get the correct dimensions.
Hmm.
So I've done that. I've done the simulation. Everything looks good. Now I just, there's the pucker factor of a $100 thread mill that's really tiny. And is it going to work or is it going to break?
Oh yeah.
That's always the question.
Yeah, I actually have. It's funny you say that. Right next to me. Let's see if I can pull it up real quick. These are M1.2 thread mills, so you can't even really see it. But
Yep.
so that's going to be.
How many
I
teeth? How many teeth does it have?
I think it's just a two flute.
So mine is 3 flute, 3 teeth. So
Oh,
it's
so
not as
this is a single flute. I'm sorry, a single row, and then 2 teeth.
yeah. So I have mine is 3 rows and 3 flutes.
Oh, that's really nice.
Um, because going to a single one was about $130 or something like that. So it was for some reason it was more expensive.
Interesting.
Not
Yeah,
sure why.
these were pretty cheap. I want to say they were $55 a piece from Scientific Cutting Tools.
Hmm. Yeah, I ordered mine through MSC,
Oh yeah.
which is not exactly cheap.
No, it really depends. You can get some great deals on MSC occasionally, and then get just absolutely hosed on everything else.
I mean, the nice thing about them, I used them when I was doing the 12 molds in 12 days. And the nice thing is that they had great variety and they were very fast.
Yep.
And for that project, those two things were important. But I generally don't order from there unless I can't find it somewhere else. But
Yeah.
yeah, uh, what was the name of the company you said? Scientific Cutting Tools?
Yeah. SCT. So
Yeah,
I actually got these from MSC as well, and they were $57 a piece.
yeah. So this is the one I have, which is same place.
Mm-hmm. Yeah. I like their stuff. They're definitely not the cheapest, but they seem to have the widest variety of everything. I do find that MSC mislabels most of their stuff. Like much of their thread mill offering is both metric and English thread compatible, but they'll only list it for the imperial thread. So like
Mm.
my M1.2 one is also the same as like I think double aught 100 or double aught 120, something like that. And
Yeah,
so
it's interesting looking at the specs because they're, it's a combination of imperial and metric measurements.
yeah, yeah. So this one's a double aught 90 to 120 or an M1.2 0.2 to 0.5 2.2 to 0.25, and they only listed it under the double aught. And so I had to go to SCT's website, find the one I needed, and then cross reference it back to MSC.
So with the watch project, the next step, once I figure out the pressure testing and get everything working with an actual body, is to start thinking about production. Their Kickstarter has been delayed because of COVID um, and various other manufacturing issues with the 3D printed bodies. But they're in pretty good shape right now, and they are going to do another revision. They've decided to change the back from using screws the way it is right now and using a thread on back.
Oh, interesting. Okay.
So that means I'm going to have to get a different thread mill
Yep.
uh, so that I can cut those threads, which is going to be interesting. The other thing is, I did use the fourth axis to cut the hole for the stem tube as well as for the strap
Mm-hmm.
clips. And the thing that was interesting about that is with the texture that's on it, it's really, really hard to spot drill to the right depth. So we've switched it so that the holes are going to be internally formed with the 3D printing just on the inside, and there won't be anything from the outside. That being said, I still am thinking about using the fourth axis for production with a tombstone, which I might have to make,
Smart.
as well as what's the name of the thing that holds it on the end? I'm forgetting the name.
Tailstock.
Yes,
Yeah.
as well as a tailstock to make it sturdier, because that way I'll be able to have ID clamps for the different operations. So I'll be able to basically have two for the first op, two for the second op, something like that.
Right.
And
So
then
you get like
also,
a complete part or a couple complete parts.
and
every
then also
cycle.
be able to drill and ream the tube hole at the same time. So that means I'll be able to do the top, the bottom, and the side, all in one setup.
That's smart.
And then I'm also planning to get a probe, because one of the difficulties with this is clocking it, because you have the stem hole has to be in exactly the right place, and there are other features that are clocked. And I've been thinking about how to clock it best. When you have the 3D printed texture, how do you clock it? Because the texture is providing some irregularities.
Right.
I have some ideas about how to do that, but then the other thing I'm thinking about is if I get a probe, I can probe it in multiple places and then average it,
Mm-hmm.
and then figure out the rotation of each part so that I don't have to get it perfectly clocked when I put it in the machine. At least that's what I'm thinking, except for the stem tube, that does have to be perfectly clocked. So I'm basically mentally going through the design of production and figuring out how to make it so that I can have efficient production.
That's
Uh,
the fun part, right?
that is the fun part. Yes. Now, when it comes to production, My goal is to make it so that either my wife or I've got a friend who likes to do this type of work can do the actual production because I would get too bored.
Mm-hmm. How many watches do you think you're going to be producing when the Kickstarter ends?
Don't know.
Okay, that's exciting though. That'll be a lot of fun.
Yeah.
Well, that brings us on to shop news and new things. What's new in the shop? I mean, you talked about the watch project. Any other new machinery or business decisions or anything like that?
So I did get a pick and place machine recently.
Okay.
I did say I was going to come back to that.
Full circle, yeah.
Um, there is so this is a commercial pick and place machine. It's a four-head pick and place machine. But when I say commercial, it's designed for small shops. So it's kind of the prosumer line of pick and place machines. And there was someone who was retiring and moving to Spain. And he had this machine, so he wanted to sell it, and he sold it for a quarter of the full price.
Oh, wow.
And it's a fairly lightly used machine, so unfortunately, that was a low enough price I couldn't say no.
Right.
Now, the problem with getting a machine like that is now that I have it, I have to use it.
Mm-hmm.
So that means I need to come up with projects for which I need it. The first project that I'm planning to use it for is, again, one of those ones that's not worth doing. I'm designing a touchscreen controller for my 50-year-old injection molding machine that is an automatic machine. This is where I mentioned that I want to have modern electronics.
Mm-hmm.
So the idea is that it'll have a temperature controller built into it. It'll allow you to set how long it waits after injecting before it removes the pressure from the cylinder, how long to cool before it opens the mold halves, sensing that the part has fallen down to make sure that it's clear before it closes the mold, etc. So the idea is to make this completely automatic. And so I'm designing that. It's actually sitting here on my desk.
Hey, look at
that. And I've got a couple of videos on it as well. So it's a bunch of wires all over the place right now. And so what I want to do is make a custom circuit board that will fit everything onto that circuit board. And then I thought, okay, that's a good use of the machine.
Right.
And I might as well sell them. I have no idea how many I'll sell, probably at least 10. You can see it's not worthwhile doing a project like this for 10.
Right.
Even for 100, it wouldn't be worthwhile doing. If I sold 100, I'd be amazed. So one of the other things that I did as part of this is to get ready is I finally set up an email address with my new domain name. So I have the domain randomproducts.net that I've had for a few years, but I never did anything with it. So I finally set up an email server. So I have john@randomproducts.net. So I can keep my hobby business email separate from my personal email. And then the next step after that is to set up e-commerce site, a website, which I haven't done yet because I have no products. But when I do have products, well, I guess I do custom injection molds for people, so that is a product. So I probably should set up the website anyway. So I was doing some research, like Squarespace, Shopify, etc. And I think I've settled on Shopify.
Okay.
So that's what I'm planning to use for the website once I set that up.
Awesome. That's really cool. Well, that brings me to the last question I ask every guest, which is, what did you research this week? And it can be, it sounds like there's going to be any number of things that you've been researching this week, but what's been, popping up in your search browser?
Well, so one of the things was Shopify versus Squarespace versus Wix, etc. And I decided on Shopify because, the main reason for setting up the site is not to have a lot of information, but for selling products. And Shopify seems to be a better solution for that. And so I ended up going with the supplier I went with for email because that's one of the ones that Shopify recommends.
Okay.
And they were cheap. And so Shopify is the next step. The other thing I've been looking into is temperature controllers. So for this touchscreen controller. So one of the things that I do when I approach products is I think about what do you want it to do first before I think about how I'm going to build it. And so in the case of the injection molding controller, one of the things that's common with injection molds is that each injection mold has different parameters you want to use, depending on the plastic, depending on flow rates, etc. And the temperature of the barrel is one of them. How long to dwell is another. How long to keep the mold halves closed is another. And so in this touchscreen controller, I want you to be able to save those profiles so that you can just recall it for a job that you've done before, because I'm really bad at taking notes and keeping track of those things. So having them in the controller is a good way of doing it. Now, if I'm going to have that capability in the controller, that means that the controller needs to be able to control the temperature.
Right.
So that means I can't just use a PID controller that I would buy off of Amazon and put that in place. That means I have to do my own.
Oh boy.
Yeah, it's not something I wanted to do, but to meet the user experience that I want to achieve, I have to do a temperature controller. So I looked at getting PID controllers that had a serial interface, but those are really expensive.
Oh, really?
You go from a PID controller for $30 that has no interface to one with an interface that's like $200.
Oh, wow. Yeah, that's a big step up.
And if I'm going to be selling these to people who have like a Beagle Buster, I have to keep the costs down. So that's not an option. So that means I have to figure it out. And so I've been researching different approaches, and the usual approach is a PID controller. Another approach is a fuzzy logic PI controller.
Okay.
So that's what I've been researching.
Very interesting. Yeah, it's I mean, you listened to last week's episode, or the one that came out last week, and Travis and I talked a little bit about how, PID controllers are in everything. Like it's kind of the go-to for if you want to keep a steady state with a few different variables. That's what people turn towards. Oh, that's pretty interesting.
And the problem with PID controllers is you have to tune them.
Yep.
So the thing I'm hoping is the case with the fuzzy logic PI controllers is that you don't have to tune them.
Oh, really? Okay.
They may not be as fast at ramping up to the desired temperature, which is okay. Because if it's easier to make this work, then that's fine. Or if it's easier to use, then that's fine. But at the same time, I'm kind of, looking at extra work writing the code for this. It's like, that's taken away from other projects. Oh, speaking of which, one thing I didn't mention is, I'm not sure a lot of people have an idea of just how much work it is to create a YouTube video. And one of the things that I've learned from this process is that my production of projects is a lot slower because I'm creating videos. So every Saturday morning, I spend the whole morning editing that week's video, which is why my videos are usually out at about 11 or 12. Because I'm not far enough ahead to have a video ready for the next week. And so that takes away from a lot of the hobby time working on these projects. And so I constantly have the struggle of, do I just do it or do I turn it into a video? And most of the time I want to turn it into a video, which therefore makes it a much longer project.
Yeah, I've wanted to create YouTube videos over the years, and just even starting down that route, it's a lot. I mean, there's so many angles you want to get, and to be a successful storyteller is much more than just accomplishing the project.
Which is where, by the way, wristwatch revival comes in. So the way that I was doing videos is by speaking. I was using the Keith Rucker approach, which is you speak through things as you're doing them. I think for his case that works really well because he's dealing with refurbishing old machines and he knows what he's doing. So things are usually not a surprise to him. He knows how things are going to end up.
Right.
But with most of what I'm doing, I don't know how things are going to end up. It's usually the unexpected. And so by recording the audio as I'm going along, quite often it turns out not to be correct. So one of the things I learned from Wristwatch Revival is you can tell that he's doing voiceover.
Yeah,
So he's
definitely.
recording everything without any commentary and then adding the commentary later. And what I realized is by doing that, you can create the story and tell the story once you know the full story. As I'm doing the project, I don't know the story.
Right.
There are lots of things I'm going to get wrong if I say them up front. So I've been switching somewhat to either that approach or a hybrid where I'm just doing the video without voiceover and then adding the voiceover later.
That's smart. Yeah. No, I think that makes sense, especially if you're doing it yourself, because I mean, like you said, I think in machining, we make a lot of assumptions. We hope they turn out how we want, and very often they don't. So,
Yeah, and this is the difference between production versus prototyping.
yeah.
I mean, everything I do is so far has been prototyping. I mean, injection molds are prototypes.
Yep. Yeah. Well, that's really cool. Like I said in the beginning, I will definitely link your channel. I haven't watched all of them, but the ones I have watched, I really, really enjoyed, and I've been following along with the watch project. I think that's super cool. I mean, I love 3D printing. It's kind of a cool crossover between metal 3D printing and machining. So it's definitely a cool project to follow along with.
Thank you.
And thanks everyone for listening. No new Patreon thank yous this week, but thanks everyone for supporting the channel to help with guests like this and episodes like this. And thanks everyone for listening. I'll be back next week.